You're now plugged into the Delphi podcast.
Hello, everyone. Welcome to a new episode of the Delphi podcast. I'm John from Delphi Ventures, and today I'll be hosting Astria, the shared sequencer network. Before we move on, full disclosure, as Delphi Ventures, we are proud backers of Astria, and I'm personally also invested in the project. So today I have Josh with me, who is the co-founder of Astria. Welcome, Josh. It's great to have you here.
Thanks so much for having me, John.
Josh, I believe we met 2 years ago when we both kind of realized the importance of data availability layers and the sovereign rollups thesis. You've come a long way since then. I'm kind of curious to hear from you your journey from that time to the present. What brought you to build a shared sequencer network? And as you walk us through your journey, feel free to share your background for context.
Yeah, so if we go like way back kind of before crypto, I've been around crypto kind of forever, but like working in it professionally for almost 3.5 years now, starting January 2021. And before that, I was just a software engineer at Google, mostly in kind of cloud, working on distributed systems, Kubernetes, App Engine, serverless, things like that. And that kind of biases how I think about, product development in crypto as a space. Within crypto, again, joining in this kind of like January 2021 timeframe, what we were seeing at that time with a lot of like, I guess what would be termed like alt L1s kind of coming around, right? You had like Near, you had Cosmos getting traction, you had Polkadot kind of ramping up, you had Solana kind of starting. And this was also when we started seeing kind of Ethereum discussing the Rollup centric roadmap. And so I spent a lot of time kind of, with my first position at the Graph doing kind of research on, what are like the scalable properties of blockchains. Because I think in that cycle, with when we first started to see kind of constraints on the throughput of kind of blockchains. And so, we saw again, like Ethereum with like, the execution charting design, and then Near being, a similar kind of concept to that, as well as a lot of the other, like, L1s, whether it's like Polkadot or like Solana or whatever, starting to come in. And, I got to kind of data availability from my time looking at Ethereum's rollup-centric roadmap and coming across Celestia at the time. This was called Lazy Ledger. On like the ETH research forums, you had like Mustafa and like John Adler participating a lot in those research forums and proposing their ideas. And what kind of drew me into that was seeing, what I would call kind of like this like fractional storage option that is, provided by like data availability sampling that Celestia uses. And so prior to that, right, you had these blockchains and you essentially had this kind of like block size debate, right? Of like, how large do we want to make the chain? Because structurally, there were kind of two sets of actors. You could be like a light client user who is basically saying, I'm going to check the header and that's going to, give me some confidence that I'm on like the right, fork. But they're basically just going to trust kind of like the data coming out of like some full node from like an RPC provider. And you could also run like a full node yourself, but a full node had to store all of the data of the chain, and thus to allow people to run full nodes kind of in some local capacity, they reduce the kind of resource requirements of the chain, and that leads to kind of the overall throughput and like how fast the chain is going to go and the state growth and et cetera. And so we saw kind of in scaling, I think like two categories. You had this kind of like sharding design and kind of like DA as this like underlying kind of concept there, or you saw essentially the big block thing. And so I saw Solana as saying, look, we're going to bite the bullet, we're going to make the nodes bigger, we're going to run the nodes as fast as we can, kind of below the bar at which it is like, I'd say like enterprise grade hardware, right? Like you can still run a node on like consumer grade hardware. It's not cheap, but like you can do it, and then we saw Celestia, and the thing that was really compelling to me about Celestia was, again, this thing I'd call like fractional storage via data availability sampling. And it was this idea of being able to be a light node in the network where you store some fractional subset of the network, but via sampling, you are still kind of contributing to the ability of, someone else from kind of getting a guarantee that, hey, all the data is actually present in the network by saying, instead of me storing all the data, I might store whatever, 5%. And then I'm going to go ask, N other people in the network, and each of them are going to store 5%. And by kind of sampling through this thing, using your erasure encoding, you're going to get a guarantee that all the data is present against all of these nodes. And that felt like a very, very compelling thing. And so that was kind of the origin of how I kind of got here. I ended up going from the Graph to working at Celestia relatively early in November of 2021, and, have kind of iterated from there.
Okay. So this is a good introduction of like the importance of data availability layers and how like data availability sampling nodes kind of scale the verifiable aspect of like blockchains. But from there to actually like shared sequences, I think there's another leap, right? Like currently in the current status quo, we see a bunch of rollups. They each have centralized sequencers, and like you could just build your own chain, right, on Celestia as well. And I think like that's also like part of what you guys are also building. But importantly, you are a shared sequencer network. So how did you like how did you identify shared sequencer as being something like that's worth building? Maybe we can keep things like very simple and like give it like advantages of shared sequencers, what those shared sequencers like promise to rollups, and like a counter to that, like what do they give up if they were to opt in into a shared sequencer network? Could you walk us through those?
Yeah, so I'll try to keep this relatively concise, but give some like kind of like background context. So like we Astria kind of came to shared sequencing through the pathway of decentralized. And so at Celestia, I was working on what term Sevmos. This is essentially like how do we put an EVM roll up on top of Celestia? Like what is the design for that? Parts of that project kind of live on as Rollkit today. But kind of from that, we wanted to do decentralized sequencing for like varying reasons, both like ideologically, we believe it's like important that like you are not having a single centralized party that is responsible for all the kind of ordering of this. We won't cover like why sequencers, but I think it's just generally understood for like UX reasons people prefer a sequencer to like a base rollup. We can discuss that later. And then we kind of came to shared sequencing from decentralized sequencing by looking at kind of this like mid 2022 market downturn timeframe and talking to a lot of kind of Cosmos SDK Tendermint teams and validators, and they said, okay, we are kind of trimming our support for like what I'll call like the long tail of Cosmos chains. They were saying, there's a lot of these chains, at the bottom, whatever 50+% of them are not profitable to run as a validator. So they're trimming those. And so, at a high level, the kind of thesis on why we thought shared sequencing was kind of like necessary as like an architectural design was we thought decentralized sequencing was important. And if we believe there are going to be more rollups than there are sovereign chains, right? Chains that run their own like full validator sets, then we didn't believe each rollup was going to be able to decentralize its own sequencer set. And thus we had to figure out a design where we could provide this act of sequencing in a, generalized, and the term we use is like a lazy way that can be kind of amortize the cost of running a decentralized network over like a larger number of like individual kind of like rollups or state machines. So like that's that. Going back to kind of your more kind of pointed question of like, what are the trade-offs that are going to be made here if you're someone who's like using a shared sequencer, right? Like fundamentally, right, the thing that I think is like a useful kind of way we frame things at Astria, like a shared sequencer is like a very like concrete thing, right? I mean, it's not like an abstract idea. I think there's a lot of questions around like, what does it mean to share a sequencer? Like in our view, it's like a shared sequencer is just like another blockchain, right? It is a network of nodes. They come to consensus. We use Comet BFT for that, right? And you therefore, by using it, have to opt in and accept the kind of the like technical realities of that network, right? So your block time is going to be no faster than the block time of the shared sequencer. Like you could say, okay, the shared sequencer runs at a 2-second block time, which is what we're running right now in our dev nets. You could say, okay, I'm only going to read a block every 2 blocks out of that, but you're not going to be able to say, oh, I have like a block at like a faster block time than the shared sequencer, because fundamentally what the shared sequencer is kind of providing, and sequencers generally, right, is this, we'll say like the first useful definition of finality, right? We've kind of overloaded and abused the word finality in kind of, the blockchain crypto industry, but the shared sequencer and again, centralized sequencers kind of acting as this role in a lot of blockchains today are going to say, I'm going to give you some commitment, right, to the strengths of economics or reputation or whatever that, your transaction got included, and here is the state root, and here's the block in which your transaction was included, right? So the shared sequencer is giving you that. So I think the
So
core limitation is going to be the block
just
time.
to, just to ask like one question here. So fundamentally, if I understand you correctly, right, if there's like roll up A, B, and C, they all use the same shared sequencer. Fundamentally, what they kind of subscribe to is having they subscribe to same like block time. So they're like kind of their heartbeat is basically the same, and that's like a fundamental thing that they need to be comfortable with when they use a shared sequencers. Am I getting that right?
Yeah, that's kind of the thing you are sharing. It's some kind of very reductionist frame. Like what a blockchain is providing is it's just like a decentralized kind of clock. If people like go into the weeds like distributed systems, right? Kind of the difficulty is like the clocks are mismatched across like different points on the globe and whatever. A blockchain is providing via a block height, kind of a shared kind of like temporal domain where you're like, all right, we all agree like this, set of time passed, and here are the transactions that are included in that set of time. If you have multiple rollups that use one shared sequencer, they have this shared view of kind of time and the kind of discrete notion of a new block being produced. They all have the same view of like, okay, I may only have, some fractional subset of the transactions in a block that are relevant to me, whereas other transactions are for another rollup. But we all agree that the tick of the kind of shared sequencer is kind of like one thing, and we are all sharing and kind of opting in to that reality. So I think when people think about like, what are the trade-offs I'm going to make? Like fundamentally, you are opting into saying this shared sequencer is defining the clock of my chain.
Gotcha. Okay, so that's very helpful. So that is like that can be seen as a constraint, right? That everybody has to be comfortable with. Are there other fundamental constraints and like yeah, before we move on to advantages?
I mean, I guess like there's like questions around, I guess, like, lock-in is like a large gonna be question, right? It's like fundamentally a shared sequencer is like a middleware in like a broad software sense. And when people are adopting kind of like middleware and like architectural decisions, right, their question gonna be like, what if this doesn't work? What if there's like some kind of capture and I'm a year on or 2 years on, and like, the entity which develops the shared sequencer, has gone in a direction that is like no longer kind of, desirable, compatible for me. What is the effort for me to move off of? So I think there's like various kind of design constraints on that are going to be kind of like more technical in nature. And that's like literally like, what is the code which you write to integrate with the shared sequencer? How well is that defined? How generic is that actual like interface? If you want to move away from that, how difficult is that? There is always going to be, again, why I use like kind of concrete versus abstract. There's just like a fundamental like the shared sequencer must exist as like a distinct network. It is not this infinitely kind of abstract kind of, concept. And so by using it, right, it is just producing blocks. Fundamentally, an integration is submitting transactions and choosing to consume blocks out of that and defining, I would say, like the fork choice rule of your chain as the subset of transactions that come out of the blocks of the shared sequencer. There is kind of definitionally a sense of like sovereignty that's being given up in that. The way we kind of try to kind of like ease these concerns and resolve this is fundamental. Like all of our code, is open source, MIT and Apache 2 kind of dual licensed, right? We provide kind of significant amounts of what I call like DevOps resources, right? So the mechanisms of like running the shared sequencer in like a local development environment, we provide a variety of options. We like thoroughly document kind of how you can run this. And so, if you want to migrate away from like the shared sequencer, which is this kind of like network kind of instantiation of this code, there's a relatively easy path for you to say, okay, this isn't working for me, but I can go take all the open source code and I can run that as a centralized sequencer kind of myself. There's still going to be some like kind of trade-offs that has like Comet BFT in it. You can run like a single node Comet BFT thing, but that's one of the things we kind of offer is saying like, look, we understand that people adopting something that is so core to like their kind of like technical architecture, we want to provide them like an off ramp if they want. Obviously, we would like to believe that we are going to provide kind of a sufficiently valuable service that is worth them paying those trade-offs. But we do want to make sure, right, especially as kind of entering, the market, right, and saying like, okay, why would someone pick, this versus this versus this, right? They don't worry kind of like immediately saying, oh, how locked in am I kind of out of the bat?
Gotcha. Okay. So very broadly, on the constraint sides, we talked about the block times and we talked about the lock-ins or frictions to move to an alternative option. What about the advantages of using a shared sequencer?
I think the big thing is fundamentally we see a shared sequencer again as a piece of middleware. The decision is going to be what I call like a build versus buy thing, right? So I think there's a lot of discussion on people saying, oh, well, I could build this myself and, capture XYZ kind of additional margin profit, kind of like, whatever, right? There's like less constraints on it. And I think that's just like a fundamental kind of like economic reality of like market structure, right? And what I mean by that is like, you could always theorize a world in which you as like an integrated solution build everything kind of vertically integrated up and down the stack, right? Like Apple is probably like the most clear example of this, of like a very, very large company, right? And they say, yeah, we maximize kind of profit share with it, or like profit within that, because they're not paying kind of any third parties, right? And the reality is, right, in like a competitive kind of capitalistic market, if you are buying a service from someone, you have to assume that they are baking into the cost you are paying some profit margin. And thus that is profit margin you're not able to kind of capture. And so there's like a fundamental just like market reality of like you're using something someone else built, and that is going to require you to pay their profit margin. But why we kind of like say it and evaluate that from them stance is just saying, that's like how the world works, right? This is just like, like a economic specialization, right, as just like a broad concept. And our argument is that like we need to, as like an organization, as like a project, right, create something that is sufficiently like good. And I use the term very broadly, but like it needs to provide an experience that is like desirable to an like end user, a consumer, right, a builder, at a kind of like market competitive cost. And so yes, the network itself needs to kind of like make profit like in any other network. But the idea is that like it would be more expensive for someone else to build something of sufficient quality themselves. And the shared aspect, right, is fundamentally kind of like one of these middleware things, right? You build a system with the idea that you have multiple consumers of said system, and thus you're able to essentially amortize the development cost to build the system in the first place, right, over multiple consumers of it. And thus each of those consumers, right, would have to presumably pay a comparable kind of cost of developing, an equivalent system. And so if you get, n consumers of it, and each of them is getting kind of a sufficiently kind of high quality, experience, it's better for them to say, we'll go use the kind of third party who specializes in building shared sequencers, right? Rather than us trying to develop our own in-house kind of sequencer. And how we look at the kind of market right now, right, is, we think there's like, if you kind of work in like the builder market space, right, and you're saying, I'm trying to build like a protocol or an app or whatever, and you go look at like the talent market in crypto, I think the reality people come across, there's not that many super high quality kind of protocol engineers in the space, certainly not ones kind of between jobs. So there is kind of just a reality to saying, if you can build like an entity that just has a high quality of like engineering talent, that is actually like a differentiated advantage in this market, because we don't believe if there's going to be 1,000 or 10,000 rollups, each of them is just going to be able to source and staff the kind of engineering talent to build their own solution. And that's fundamentally in kind of cloud-ish style middleware software. Fundamentally, what you're doing is charging profit margin on the salary of your high quality engineers producing some kind of like infrastructure project. And that's
Yeah.
structurally how I see a shared sequencer.
Okay. So on the advantage side, basically, if I were to summarize this point, it's basically amortizing the cost of engineering and building this middleware stack. But there, there is the assumption that there lies the inherent assumption that like rollups will eventually gonna need this middleware, whereas like in the current world, we have just like centralized sequencers. So if we were to fast forward, the fast forward a bit, like how do you see things unfolding? Like, do you think rollups will rollups will use shared sequencers because they are like kind of forced to decentralize their sequencers, like maybe due to regulation, and then at that point, like why not just use a shared one? Or do you think like there could be a world where like something like superchain or arbitrum ecosystem still operate on a centralized sequencer, but it is a shared one where like all the rollups within that ecosystem are shared by that? Because I can see like both worlds kind of like both scenarios. So yeah, I'm curious how you see things like unfolding here.
Yeah, so I guess I'd say there's like two broad categories of like consumers of a shared sequencer. And I guess what I mean by that is like you have your existing, incumbents is too harsh of a word, right? But you're like like your established players, right? And so this is gonna be your Optimism, your Arbitrum, your Base, your ZK Sync, your Scroll, Starkware, et cetera, right? These like
Yeah.
large entities, right? They have presumably raised multiple rounds of funding. They have a valuation somewhere in like the billions of dollars. They
Yeah.
have presumably some amount of kind of ecosystem and established thing. And specifically, again, to my earlier point, they're going to have like engineering talent, right? Usually these are teams who kind of invented like what a rollup is, right? They built the kind of initial implementations of these things. They did the research, right? They did the engineering, they did the development, and so we're not kind of targeting those entities because fundamentally we think they're like they're bigger players than us, right? They're just like larger, more established entities. We are fundamentally like a startup, well behind them from like a quantity of people, a quantity of resources, right? Like a time in the market thing. And so we don't assume they're going to come consume our kind of like startup-y like middleware software, right? Fundamentally, they have the talent and the resources and the cash flow and the engineering expertise to build a shared or decentralized sequencer themselves, right? And I think we're generally aware that like, most of the existing kind of like large rollup players are investigating decentralized sequencing. I don't want to kind of like, spend too much time discussing like, FUD or whatever around kind of like regulatory kind of pusher, right? Like no one, at least I do not know, right, like what the SEC's opinion on like rollups is. Presumably there's someone within the SEC who knows what a rollup is, but I assume that it is not the majority of them. We'll see how they feel about that when that becomes something kind of top of mind. But generally, these regulatory agencies are going to lag. So I don't want to worry about like, what is the regulatory pressure? I think there is a question of kind of like ideological kind of concern, right? Of, how do people feel about, essentially saying, hey, there's like one node, right? Whether it's one node, it's distributed where, but there's like one entity which kind of like owns the kind of production, right? Is that censorship resistant? Again, is that like a reg question? Is it just like a distributed systems problem, right? Of just like, that node goes down, right? What is your kind of like, number of 9 kind of reliability? I think that's like an easier to resolve problem. You can do, fallbacks and distributed things that are not kind of like decentralized from like a number of actors. But what I'd say is like we're more focused on the second category. And what that is right, like these chains that do not exist but believe, or more application developers who might say, well, the way in which I want to develop my application may want to have kind of its own block space, right? It may not want to be a smart contract on like an existing general purpose, whether it's an EVM or an SVM or Move or whatever, right? They say, I want to have my own kind of like chain, and I want to have kind of control over kind of the, whether it's the fee mechanism or the throughput parameters or whatever, right? And so they say, look, a roll up or my own chain or whatever is going to be the kind of thing I want to look at as like a technical solution, and then go evaluate in the market, right? What are the options for how they can do so, right? And what we're seeing right now is like we're seeing quite a few like L3s launching generally on like Base, right? They're using like the roll up as a service providers, right, to do so and kind of hosting that. And so that's more the kind of market we're looking at there. And I think the big question is going to be for these players, the big difference is going to be say it's out of scope for them to go build something themselves, right? Fundamentally, they're either going like they're going to buy, some significant amount of their tech, right? They're taking, the OP stack or, Arbitrum Orbit, as like off the shelf kind of like open source, software, and they're going to use that as their base. And then they're going to go out and pay a roll up as a service provider to kind of do the hosting and the management of the actual kind of like infrastructure, whether, wherever that's running on like the cloud or whatever. So they're already in this sense of I am an application developer and I'm already outsourcing a significant amount of my kind of infrastructure, spend, build out kind of technological expertise. And so as the market more we're looking at, to your point on kind of like, earlier, like limitations of a shared sequence, there are trade-offs. I think the big limitation we have from like a market thing is the reality of like, we're not mainnet, right? And what that means is that like, we have a new network and no other network can kind of build on top of us until we are like live in like we have kind of blessed this thing. It is a mainnet network. It is ready to go. Whereas in these kind of centralized sequencer things, right, individual networks can kind of launch with their own kind of like timeline because they're kind of holistically controlled. So that's one of the big gaps in the market right now is like, we just need to get a product out such that other people can build on in a mainnet capacity. But in the broader trade-off space, right, a lot of this I think is like very speculative, right? It's just gonna be a question of like, what are the market structure that people are going to pay, right? If we look at like conduits pricing, right, they're charging somewhere in the ballpark of like $3,500 a month for like a roll up, right? And then they're also charging like 7.5% of like, revenue off the top, right? And so the question is like, is that like the sustainable market thing? Is that the cost to outsource? Can you provide kind of a competitive experience in, a shared sequencer kind of with that, and then additionally looking at the architecture of a shared sequencer, right? What are the benefits you can provide? Whether this is through, potentially like more optimal interoperability with other rollups in the shared sequencer network, whether it's through, the ability to provide like plugins or whatever kind of in the shared sequencer and these kind of value add services. I think that's going to be the kind of open question in the market is like, what are you able to provide that makes your solution more appealing in the kind of market to these customers who are already deciding I'm going to outsource a large portion of my kind of technical expertise to get my product out.
Okay. Yeah, this is very helpful. So, so the way I understand, basically, at least like today, right? When you look at the market from a shared sequencer kind of perspective, there's existing like large ecosystem roll-up ecosystems out there. That's like not the target base, but you're basically your addressable market is basically like thousands of rollups that can spin out and then like continue to spin out like every day almost now. So I guess one question that's like many may have there is like where like how does like the value accrual looks like in such a world where like rollups all tap into like the same shared sequencer. Do you have any like intuition in terms of like um ballpark, like how the like how much of the value that the rollup generates like can be captured by the shared sequencer, whether that be like because if that's like too large that can incentivize and it's like if it's yeah, I just curious to get some color
Yeah.
on that.
I mean, like fundamentally, right, from like a roll-up developer's perspective, right? Whether they're like an app specific roll-up, a general purpose roll-up, right? We assume they're going to be looking at the shared sequencer as, essentially like a cost, right? It's going to be like your kind of cloud compute cost if you're like a web 2 company, right? You're saying like,
Hmm.
I am creating a product and that product must have some kind of like physical instantiation, and I'm going to go buy that from like a third party, and that third party is going to charge me kind of a rate on that. And I think the question is kind of saying, what are, from like a first principle thing, right? There's like, what are just the fundamental cost to do so, right? And so you have kind of, for us, we're starting to like focus on like Celestia. And so you have what is like the just raw data cost of posting data to Celestia, whatever the current price is for however many bytes there are, right? So that's going to be your kind of like initial cost, right? And if we compare that to the existing kind of larger roll up market, right? We saw going back, 2 months ago now, right? Pre 4844, right? A significant amount of the cost of these rollups was paying for call data on the L1. Those costs have come down relatively dramatically with blobs. We're still seeing new rollups. I think Scroll was like today or like yesterday or something just like rolled out their upgrade to move to using blobs. And so we're going to see if that blob market becomes more congested and those prices go up. But like that's like one fundamental base cost, right? It's like where is like the DA being posted? And we at Astria kind of act as like an abstraction layer where we assume that the cost a person is paying to use our shared sequencer is including the cost of us on their behalf posting the data to the DA layer, right? So
Right,
they're not kind
right.
of having those two things. And then I think the big question kind of becomes, what is that cost? What is like, I'd say like the market bearing price for whatever application the actual kind of like developer is working on, right? So generally when we look at kind of an app on like a general purpose chain, right? There's going to be a couple costs, right? Let's just think about L1 to kind of like simplify this, right? I'm going to go deploy whatever like Uniswap on like an L1, right? A user is going to use it. They're going to pay, whatever kind of fee is the front end, right? Whatever Uni Labs is like paying on like their fee switch or whatever, right? And then they're going to pay whatever the like protocol, right? In this case, the smart contract is charging on that. I don't, follow it, but like, is Uniswap charging like a contract on the protocol? And then they're going to have to pay like the chain's kind of like base cost, right? And so our view is that like the shared sequencer and thus the DA layer implicitly is essentially going to be like the chain base cost, right? And that then there's like a more kind of like flexible kind of domain for like the application to say, okay, I have my own state machine here, right? Whether it's an EVM, SVM, move, whatever, right? And they are going to get to decide, how they choose to kind of expose costs to like an end user, right? Where what we've seen with like some kind of applications, right, using like Privy or other kind of abstractions is, I'd say like a cleaner like user experience, right? Where instead of a user saying, well, okay, I'm going to get hit by like a fee on the front end, and I don't know what that is, right? That's calculated some way, and then a fee on like the smart contract level, and then a fee on the chain level. If you have like your own application specific chain and your own rollup, right, you say, the user is just going to get a fee, right? And like I, as like the developer, may control all layers of that, right? They may control like the front end, the contract, and the chain itself. And then their base cost is going to be this cost of like sequencing and DA, right? And that kind of sequencing and DA cost is fundamentally kind of just dependent on like, there are just nodes in a network and like people need to be paid to operate nodes in that network, right? I think we've seen Dankrad's been probably like the loudest proponent that's talking about how like L1s overpay for security, right? Like too high of a percentage of the overall kind of like capital flowing through the system is going to the proposers. I think that's a big question we're going to kind of evaluate over kind of the next, whatever, like 6, 12, 18 months is like how much fees need to go to the protocol to make it a sustainable ecosystem versus going to the applications, because then the applications kind of have more control over their fee mechanism, right? So we've
Right.
maybe tangented a little bit here, but I think the big kind of fundamental thing that we look at, right, is like I'm very much like a market guy, right? Like the market is going to define what is like the kind of competitive rate for providing people with like a rollup, right? Whatever that means, right? On like a given framework in a centralized capacity and decentralized capacity with whatever plugins, whether those are offered by, a RAS provider or by like a shared sequencer. And, all of these are going to look a lot like middleware in a kind of traditional sense of saying, look, I'm going to go buy a solution. I am a person, I'm developing an application. I need my EVM. I want it to run at this much gas per second with this block time. And I want these different plugins. What is the market rate going to kind of give me there? And I think the big question for us is the architecture of a shared sequencer relying on like a distributed network and the kind of like architectural benefits it kind of may provide, is that going to be able to be cost competitive in the market against, more centralized providers? Are we going to get a regulatory tailwind that says, hey, yeah, maybe the centralized providers have a lower cost because just definitionally they're running fewer nodes? Is that going to get kind of pushed out of the market? And then the last thing is just kind of an ideological question, right? Of like, where do we find that line between saying, well, I'm a developer building like an app specific rollup running on like a centralized sequencer. And yeah, sure, you're writing like DA to like, a base layer, right? And you fraud like, at what point is a regulator or just, your customer is going to say, that's just like a SaaS app. And like, yeah, you have like a slightly weirder kind of like technical architecture for your SaaS app than like, you're not using like MongoDB or like, whatever other, Spanner or Cosmos DB or, whatever other, Cloud DB, you're using like Ethereum as your database. But fundamentally, there is like one node running in a cloud that a user kind of interacts with. SaaS. So I think these are kind of the questions that we're going to evaluate. Fundamentally, I don't think the market has like an answer to this. We're more looking at where we're at in 6 to 12 months.
Right. So many things I agree with you, are unclear what prices of those will look like. But intuitively, do you think shared sequencer is like has a network effects where and like over time it becomes like a winner kind of takes all market, or like and you can respond this question in different ways, right? Like personally, I think like each kind of roll up ecosystem will have its own shared sequencers. So maybe they are winner takes all, but it is like pretty much within their ecosystem. Do you like? I kind of see it that way, but
I guess it's kind of a question of like, where are you like drawing the line at like the market and like the ecosystem and takes all of what I know that's like very abstract, but like like you could theorize, right? If say like we had no roll up, right? We had like we were like base roll, we had no roll ups, right? And then like a shared sequencer was like the first thing on the market, right? Like that was like the way in which like everyone started building their roll ups, and like the first 3 roll ups all used like a shared sequencer, and no one had like an independent sequencer. Then I think like there is like a path dependency that leads to like that shared sequencer capturing like something 90% of the market or whatever, right? But where we're at today, right? Like shared sequencers are like starting to kind of like get close to kind of going to market when we already have whatever 10, 15, 20, whatever kind of like roll-ups, of which 5 to 10 or whatever of like sufficiently large size that I think it's relatively unlikely kind of they would go to a shared sequencer. And then also, right, there's a lot of kind of questions of like, kind of like how happy-go-lucky, like we're all friends here kind of thing are we going in like the roll-up landscape versus like, no, like, yeah, we're all like Ethereum aligned or whatever. But like, Optimism and Arbitrum are like directly kind of competitors with each other in some business sense, right?
Yeah.
And so if you see kind of like, one of those ecosystems say, I'm going to use shared sequencer X, the other one is probably less likely to use that shared sequencer because they're already established and they want to have kind of control of their ecosystem, and they kind of get like disintermediated by having some existing sense of kind of community ecosystem, whatever, and then sharing that with their direct competitor. And right. So from like a path dependency thing, we already have a bunch of kind of established ecosystems that are trying to differentiate each other from each other, right? Your Arbitrum, your Optimism, and your Starkware, and your ZK Sync, and your Scroll, and whatever, right? That I don't think it's going to be like all of those are going to go to a shared sequencer. Maybe none of those go to like any kind of shared sequencer. Maybe you see, Optimism, I think, has like the clearest path here, right, with their super chain to say, hey, if we think that it is like useful from like a kind of composability perspective or an architectural kind of like design space to have, the super chain have kind of like one shared set of like, decentralized or whether centralizing shared sequencing for various chains within the super chain, I think they would do that themselves, right? And I don't think that would have like an overlap with like, an Arbitrum or like a ZK Sync or whatever, right?
Yeah.
And so for that reason, right, there's no way I don't think from like a what the roll-up market looks like now by like percent of whatever volume or TVL or however you want to calculate it, transaction flow, it's not gonna be like 90% goes to a shared sequencer because it's already split among enough entities that are kind of directly competitive with each other that they're unlikely to kind of couple, right? And so again, then it's kind of a question of like, okay, maybe there's, a couple shared sequencers. And, frankly, there's not that many different projects working on shared sequencers. There's really like 3 or 4. And so generally you see in these markets, right, you see like a 1, 2, and like a middling third, and a fourth is irrelevant, right? And so if we have like 4 players in the market, right, that's kind of like the competition that's happening here. But I do think it's kind of a big thing of like, the shared sequencers acquiring kind of like which customers, ecosystems, whatever, and versus the existing established ecosystems and how that split works.
Um, I'm curious to get your thoughts on, generally, like broadly, on optimistic versus ZK as well. I think that like landscape really is changing like almost every month now. Like, initially people I mean, initially people generally had the idea that like optimistic was going to be, more practical way sooner than ZK. But I think like ZK tech is like significantly progressing and like kept progressing over the course of, months, years. In like from the perspective of shared sequencer, is there like advantages to being a ZK rollup than optimistic, because like proofs can in theory be kind of composed with each other, aggregated? Yeah, does, in your mind, does that bring like advantages to ZK rollups, or not really, or am I missing like anything here?
Yeah, so I guess a couple things. Like, well, one, I'm not like like an expert in like any of those things. I
Sure.
spent more time working on optimistic rollups at like a research level than like ZK rollups. I'm not a math guy, but I guess one thing would be like, I view sequencing and the bridge as like distinct phases, in that like fundamentally, right, like the optimistic, fraud proof, fault proof, whatever, or like ZK proof, validity proof, succinct proof, whatever you want to call these, right? Fundamentally, they're about bridging, right? They're like bridging assets like to a rollup. And generally
Yeah.
they're on like the withdrawal path, right? Of saying like, okay, I have bridged some assets from some L1 up to some like L2, right? And now I want to withdraw from that L2 to the L1. The L2 is fundamentally just like at like a fork choice rule, just like defined to be kind of subservient to the L1, right? In these smart contract roles. So it is just like already making the trust assumption on the L1. Therefore, that bridge is easy, right? From the L1 to the L2. From the L2 to the L1, right? The L2 has this kind of subservient relationship to the L1. So the L2 has to somehow prove to the L1 that its thing is valid, right? And what
Yep.
we didn't want to do is kind of design this kind of like multi-sig structure, right? Or something that looks like IBC, where you say, okay, I have some validator set. It makes some economic attestation to some, 2/3 majority signed, state root and makes the attestation. That's your kind of like economic trust assumption on the bridge. Because the point of a rollup, right, was to have like a smaller number of nodes you need to run that, not just being the kind of Cosmos or like Comet BFT, Tendermint, whatever ecosystem. And so the two solutions that came out of that were like, fraud proofs or like succinct validity proofs, right? And I spent more time again on like, optimistic or like fraud proofs, right? And I think those were kind of the things that came out of like, the plasma group, now like Optimism, right? And like the Arbitrum guys been working on this for like almost like a decade now, right? On these kind of interactive verification game proofs, right? And like various iterations. And I guess so, trying to kind of like not be too long-winded about that, though, it's just my nature. Fundamentally, I view the sequencer is like a distinct entity from the proofs. You generally, as like
Right.
a phasing, you're gonna have some DA layer. You made have like some sequencing on top of that. You're gonna get like a state root out of that, and the bridge is just someone making some attestation about the validity of a state root to enable a withdrawal on like the L1, right? And so you can do that for like a multi-sig, or you can do that for like a centralized party, and that centralized party can either be backed by a bond or whatever, right? Where they say, I'm going to make this claim, and then if a fraud proof, they say someone has a mechanism to challenge me, and the strength is to some like economic bound or whatever, right? And then the
Right.
validity proof saying, I'm going to go generate a proof, right? I guess my view on the technology generally, what we've seen, and we've seen a lot of progress recently, like Bolds, it's like almost like a year now since they've kind of announced that. I think they just moved to a test net today, or just announced they're moving soon. The Optimism guys have their fraud proof work on Sepolia testnet, I think, now, right? So we've seen some of that. But generally, what I've seen in kind of the optimistic landscape, and my kind of, somewhat layman, but a little more than layman, kind of engineering analysis of the problem of like fraud proofs, they feel like this very like, you can get 90% of it working relatively easily. And it's very hard to get confidence that that last 10% has no edge cases, corner cases, whatever. And I think that's what we've seen in the last like 2 years, right? It's like, yeah, the MVP looked good. Now he's got to double check, and that's just a long process. And that's what we've seen. Compare that with validity proofs, where we got the like, hey, we can generate a validity proof. It just took like whatever, like 12 hours or 24 hours or like $10,000 or $100,000. It was like extremely expensive to generate it. but we had the like defined, like, here is like structurally how I generate a proof out of like a given, like, state DB, state root, whatever, right? And over the last, N years now, we've just been really grinding at the kind of performance and cost there, right? With a bunch of different things, right? Starkish, plonkish, whatever, right? And all this stuff. And so we've made a significant amount of improvements. And I'll note, I'm a little bit out of touch with like the most kind of recent thing on ZK. I didn't make it
No,
over
this
to
is
like Athens last week, but that's my view. The last bit
this
I
is
I
yeah,
do think
this
there's some like interoperability benefits to validity proofs, but I think it's all constrained on cost mechanism, right? Like Justin Drake spent a bit of time a couple weeks ago talking about real-time proofs, and that's like a intra-block time kind of proof generation. I am not optimistic on that happening in like 12 months. That would be really cool, but I don't think that's going to happen. But yeah, it's like long-winded
is
kind of.
is pun intended in the optimistic term there?
Not quite intended, but there's only so many words in this space.
No, this is great to hear from you. Actually, and I like directionally very much agree with you, right? And the context with the 90 and 10%, I think it was quite interesting. Okay, so I want to also ask you about base sequencers, because it's just such a hot topic. First of all, I'm going to ask you to define this for us, because I've heard like different definitions from different people, and I'm curious what do you understand when somebody says base sequencing? And the second question is like, what you're building in Astria, is that like potentially compatible with base sequencing, like complementary, or is it basically an alternative to it?
Yeah. So I guess the original definition of like base sequencing, and what I still kind of like accept is like the default kind of starting case. And I think Tycho has been the people who have been kind of working the most on like building a rollup that uses like base sequencing, right? Is the idea that the block production of the rollup is like purely dependent on the block producing entities within the L1. I'm trying to kind of figure out my jargon, right? But like the validators, block producers of the L1 are the entities also producing the block for the L2. And so base sequencing in the kind of like original definition, right, just like doesn't have a sequencer, right? Whereas what we have in kind of existing rollups, right, is you have some third party sequencer that is some, in broad strokes, there's a smaller number of sequencers. Right now we have like one, right? There are a smaller number of sequencers than there are like L1 block producers, right? And they have higher resource requirements and run faster and provide a higher quality user experience. And so base sequencing at like the simplest kind of definition is just saying, we just run the rollup and we just post raw data to the L1, and we still have like the node software that defines how you derive the state of the L2, the rollup, right, is reading that raw data, but the execution only happens on those nodes. And thus you kind of get like a compression benefit, right, of not paying the execution cost of the L1, only the data cost of the L1. And that is like the simplest base sequencing. I will pause there, but there's obviously from like the recent discussion on that, it's like base sequencing with pre-confirmations. Probably worth discussing that and talking about like kind of like Astria, but like want to make sure we're at least kind of in agreement. You want to proceed with like, going into the weeds of like what is the current discussion around base sequencing and how that word has been used in like the last 6 months.
Yeah, I think pre-confirmation, we can get into pre-confirmations. And as you speak to them, like you can maybe talk a bit of trade-offs between like base sequencing and like shared sequencing in the way like Astria is building. Yeah.
Yeah. So I guess to start, I guess I would define at some level, I would say a rollup which uses a shared sequencer, or at least a shared sequencer as Astria's design, right? As this kind of sequencing layer, this like new blockchain, it has its own kind of validator set. It is coming to consensus over the bytes of transactions that are rollups, and that rollup is assumed to then run a full node that is deriving a kind of state out of this like relatively, like from the shared sequencer perspective, like lazy or like low context kind of data. It's just coming to consensus over like raw bytes. And then the rollup node derives out of that and kind of applies the context of its state machine over that. That is fundamentally like the rollup is like a based rollup of the shared sequencer. It's like that is like our assumption of the design, right? It's like there is no other layer of sequencing that is even faster than the shared sequencer. You just have user transactions go in the shared sequencer. It produces a block. You execute the kind of state transition function over the block, right? So using the like classical kind of definition of a shared sequencer. If we look at kind of what's been discussed recently on kind of shared sequencing or shared sequencing with pre-confirmations, right? Fundamentally, I guess my view is that gets quite muddled, because when we talk about pre-confirmations, right, fundamentally, right, there is some set of actors and software run on hardware that has higher resource requirements than the resources to run like the L1 validator node, right? So if like you look at Ethereum, right, it's like whatever, it's always been like the $1,000 laptop or whatever to run a full node. If we want to provide pre-confirmations, right, fundamentally, there's going to be some assumption of like a higher resource requirement to do a thing faster than like the L1, right? Like that resource requirement is going to be higher. And then just, again, very, very broad strokes directionally, there will be fewer people running kind of like these pre-conf nodes, however they are kind of structured, than there would be the L1. So a high level, my view is like, I'm not convinced that like base sequencing with pre-confirmations is truly base sequencing. I would like argue that we just like renamed a thing called a sequencer. And I think the discussion that we're seeing in kind of base sequencing with pre-confirmations directionally is a question of kind of the economics and less so the kind of mechanical node things. It's this question of like at an L2, right? Use like optimism, for example, right? It has to pay some L1 cost and like, go back whatever 6 months. And it was like somewhere in like the 25 to 50% or whatever, right? Maybe as high as 75% of its cost was buying call data on the L1. Now with blobs, a much smaller portion of the total cost of running that L2 is going to the L1. And of the fees that an end user of that L2 is paying, a much larger portion of those fees are going to the L2 entity that is running the sequencing node, right? And so when we look at base sequencing, I think fundamentally what it is coming out of the kind of like Ethereum Foundation and L1 space is saying, well, we want to be able to provide rollups with the functionality to have these fast pre-confirmations, right? Whether it's a 2-second block time, a 250 millisecond block time, whatever, but this faster and better UX for their end users. But we want to do so in a way in which the economic value is kind of flowing back to the L1. And these L2s are not seen as these like distinct entities which capture whatever, right? Like 50, 75, 90%, whatever of the total like user transactions that they pay in, and they pay a much smaller percent of the L1. It's the L1 wanting to offer some kind of functionality. But I guess my view would be fundamentally what's unavoidable is there is going to be some piece of software that's going to be different than an L1 validator node software, guest lighthouse, whatever, that's going to be run by a smaller number of entities. And the ones we've seen proposals for like a relay-based design for like a gateway, which is maybe the same thing as a relay, maybe not. We've seen ones where it's the block builders that are kind of providing this. But like all of these still say like there's going to be a smaller number of higher resource requirement software run. And the big question is, where do the economics go? And I think that goes back to our kind of like original, earlier discussion, right? Of when we look at the market space of I'm a person, I want to develop an L2, right? Whether it's I want to be app specific or I want to be general purpose, whatever, right? Do I want to go to a shared sequencer and pay whatever the shared sequencer's rate is to submit transactions to this kind of network and get my blocks out of that and get the censorship resistance and decentralization guarantees out of that kind of block production and have your liveness depend on that network? Or do I want to go to a RAS provider and say, okay, well, this person's going to give me some kind of contractual obligation that says I'm going to give you like an SLA with like 3 nines, and if I fail those 9s, here's the rebate you get, and you're going to buy into that kind of thing? Or are they going to say, well, the L1 is also offering some means of providing me pre-confirmations at some other cost, right? And fundamentally, we're just looking at like, what is the developer that wants to build a rollup, and where do they kind of want to like buy versus build their own kind of tech, and what are the kind of trade-offs they're going to be making in this space? And I think there's just going to be a range of options, right? I think last point I'll make on kind of like base sequencing and where we're seeing kind of the intersection of like base sequencing and shared sequencing, mostly with like, kind of like Espresso's work in this area, right, is similar to the question of like, are shared sequencing going to be like winner take all? There's this difficulty if you have, where your optimism, your arbitrum, that are kind of like different camps, right? They're like competitive with each other at some level. And so they don't want to use a shared sequencer because they want to be more differentiated from each other than more similar to each other, right? They're working in a competitive market. They don't want to be commoditized. However, they have already both accepted one shared dependency, and that is like Ethereum as their L1, which they use for like settlement and DA, right? And so what we're seeing in this kind of intersection of base sequencing and shared sequencing is I think people looking at the same thing, well, what is the shared dependency between these existing large rollup platforms, and what thing could we possibly kind of, like where could we possibly find a wedge to offer them this shared sequencing? And they look at the L1 because that is the kind of shared dependency that both of these ecosystems have already made. And therefore, there's like an idea that you can say, okay, it's not some third party thing that I'm going to use that my competitor might already be using, and therefore I don't want to use it. It's additive functionality to a layer we are already kind of comfortable and have been comfortable sharing. And so that's a lot of my view on why we're looking at this intersection of shared and base sequencing. From the kind of Astria perspective, again, this is not kind of where we came about. We are not generally like an Ethereum aligned kind of project, right? We came out of kind of my time working at Celestia. We have not spent any real resources looking at Arbitrum or Optimism or trying to convince them to use our shared sequencer because we're going to market using Celestia as our DA. And I never had the assumption of these flagship rollups moving over to using Celestia as their core DA. So they were just kind of out the market anyways, right? But I spend time and my team spends time paying attention to the base sequencing design space because as I noted, right, a rollup building on a shared sequencer fundamentally in like an academic definitional case, right, is a based rollup of said shared sequencer. So it's useful to pay attention to this kind of like research and design space and see how the market's going to kind of evolve here.
Thank you, Josh, for all those information. Definitely very, very helpful. My last question, I want to shift gears a bit to the BD side and like go to market strategy. I'm curious, like how you said you're not live yet, but how kind of how close you are to mainnet, and then as you approach to mainnet, what will be the go to market strategy of Astria?
Yeah, so generally, I'd say from like a project perspective, we've focused very little on kind of BD and go to market and marketing generally, right? I think like no one would kind of say like, the Astro guys have like marketed very heavily, right? Like, no, we just haven't, right? We don't have like full-time marketing people. Internally, our team is by and large like 85+% engineers, right? And we focus on kind of building the core product. And so when we think about how to go to market, really we're looking at kind of what things can we do to demonstrate the viability of the technology that we built that we think is good technology without kind of spending a significant amount of resources trying to build expertise in what is not our core functionality, whether that's BD, go-to-market marketing. And so what we're doing is kind of vertically integrating and building our own, rollups on top of the shared sequencer. Because when we go into talking to kind of potential kind of users, customers, right, there's a lot of kind of questions around, is the shared sequencer kind of going to work, right? Are these things that fall in like the general kind of crypto, like infra vaporware space, right? It's not live yet. When's it going to be live, right? I might say 3 months and they might say, yeah, a lot of people say 3 months and then it's 12 months, right? So there's just like a strict, like people reasonably, I think, based on how kind of crypto as a market has just kind of delivered, right? Over promise, under deliver historically, people are not going to kind of make a commitment to say, I'm going to build a foundational component on a thing which isn't live yet. And so our general view is like, our marginal dollar on like kind of BD go-to-market partnership work is going to be much better spent post kind of like, getting a mainnet chain out that demonstrates it's not vaporware. And then the other thing is, again, we're middleware. It's difficult to sell the first customer on middleware because they're going to say, I don't want to be the guinea pig, right? And from our view, right, fundamentally having kind of like third-party users of the product, right, has higher communication overhead, just like definitionally, right? And so we're planning to kind of vertically integrate, whatever, like eat your own dog food kind of style, because it doesn't require us to kind of staff a lot of like BD go-to-market resources. It doesn't require us to try to spend a lot of effort convincing someone to be the guinea pig. And then when we're kind of being the guinea pig ourselves, we have a lower communication overhead kind of internal to the organization than we do with a third party. So we're working on our own EVM. We're going to launch that EVM on top of the shared sequencer. And the kind of idea here is to show rather than tell. And what I mean by that is like, people are going to ask, the shared sequencer, it's decentralized. It's going to have just like slower block times than like, a centralized sequencer. Is it going to provide like a good enough user experience? Is it going to be cost effective enough? Am I going to be able to justify paying the cost of the decentralized like sequencer set versus just having like a one node kind of, centralized sequencer? And we can spend a lot of time and energy just like having these conversations, trying to convince people of this. But it's going to be much easier if they say, look, we're going to build the thing. That's where we're, experts. We're just like protocol engineering, right? We're going to build the thing. We're going to launch the thing. We're going to put an EVM on top. We're going to say, go use it, right? And see if that is providing a sufficiently good user experience for you, that is infrastructure that we have well-defined, well-documented APIs and integrations to build on top of. And so generally, we're kind of looking at that as like a next phase where we're going to go to market with our own EVM. It's going to be focused on the Celestia ecosystem, right? And we're going to demonstrate that like we believe the technology we've built for like the Astria shared sequencer is providing a high quality both developer experience and end user experience for rollups built on top of it. And then we're hoping that is kind of sufficient to attract interest for, what is right now, quite frankly, like a relatively small market of people interested in building kind of new rollups. But we think we can make kind of a showing in the market and say, you could also build on top of this and get the same kind of quality user experience off of our tech that we have demonstrated through our own vertical integration.
And then is there is there like a rough kind of timeline that you have in mind? I know you guys are in DevNet right now. You're transitioning into testnet. What is like the ETA looks like very roughly for Astria?
Yeah, so I mean, it's like months, not years thing, and it's
Yeah.
maybe month or months, not weeks. But like soon, we've gone through an audit on a lot of our core stuff. We've had, 3 public dev nets. We have like a 4th dev net running that we haven't kind of like announced yet. We're probably going to do another iteration. So we're kind of in the kind of like what I'd say like the final innings. And I think generally we do development a little bit differently than a lot of other kind of crypto infrastructure projects. In that myself and my co-founder Jordan come out of a kind of big tech and also like a cloud kind of like environment where we have a lot of expertise with kind of running infrastructure. And so when we say a dev net, fundamentally what we mean is like we're running all the nodes. And when we say a test net, we're saying, oh yeah, okay, like the, whatever, we're having like validator organizations run like the majority of the nodes. We might be running one node, so we have observability. We focused on kind of doing a larger number of dev nets and iterating much more on having dev nets prior to going to a test net, because fundamentally we don't want to waste the validator organization's time saying, hey, look, I can find most of the bugs by running, my network across multiple regions within my cloud and simulating latency, whatever. So we've done a lot of that. And so we haven't moved to a test net yet, but our assumption is that when we move to a test net in, the coming weeks here, ideally we're not actually finding anything new there, right? We're just saying, hey, is our documentation on how to run a node in our network sufficiently good for you as like a testnet validator? We're not trying to say, hey, here is where we begin to kind of find issues in a distributed network that we may not have found. We're hoping we found all those issues in our devnet. So, I don't want to give like kind of a strict time, but we're looking at like order of like, months or months before we get kind of something out. But obviously all of this is dependent on, we're still in the very, very final stages of an audit and getting the final report for that. Generally, right, there's had to be iteration during the audit phase. So, we have to look at, what we're doing for audits, what our comfort level on kind of go to market is, go through a testnet process and make sure that we're confident in kind of how the network is actually running, how it runs under kind of load testing. We've seen a lot of different networks, right? Basically have varying congestion issues. We want to not find those out in mainnet, right? So we're going to stand up, our next devnet, our test net, right? And we're going to kind of like load test the thing ourselves and say, okay, do we have confidence this is going to be able to go to market and not just kind of crash if someone puts on, or whatever your kind of like proof of work mining thing, day 2 of your network and it just dips because, inscription spam or whatever. So
Yeah.
again, we're kind of moving to market ASAP, but we're generally kind of having a relatively kind of conservative engineering culture here, and we want to make sure everything is working, before we go out to market.
Thank you, Josh. It's always a pleasure to chat with you. I really appreciate you sharing your insights, and was very excited to learn more on Astria. Thanks for joining.
Yeah, thanks, John, for having me.